Congratulations on what is likely to be the most rewarding project you've ever embarked upon, the building of your own Rotorway International EXEC 162F helicopter. We at Rotorway International have done our utmost to provide the best service possible from the first day we had contact with you, and you can be assured we'll continue to do so. Locate the box that contains your documentation. It will be clearly marked. Inside the box will be your packing slip, the warehouse picking list, the construction see-do manuals, the construction prints, the templates, the operations manuals, and the EXEC 162F parts list. The EXEC 162F numbering system is used for every individual part and group of parts in the helicopter. The helicopter has been divided into 31 component sections. Each component has an identification number of 7 characters. As an example, E17-6000 tail rotor. The first 3 characters, E17, indicate that this part is in the tail rotor component section, and the last 4 numbers identify a specific part within that component. Another example, part number E17-6150 is the tail rotor shaft. The exception to this rule is that all hardware in the helicopter has been given an E00 part number. Any E00 numbered hardware could be used in various places within the helicopter. As an example, E00-2300, which is an AN3-4A 3/16 inch by 1/2 inch bolt. The first thing each builder should do after opening the documentation box is conduct a complete physical inventory of all the parts shipped compared against the EXEC 162F packing list provided with the shipment. If we have back-ordered a part, it should be noted on the packing list as back-ordered, and it should not be in the shipment. If you find a part missing that we have not indicated as back-ordered, you need to contact the factory immediately so we can update our records. We request that this process be done within the first 15 days from receiving the shipment. This time frame allows for discrepancies to be corrected while they're still fresh in everyone's mind. Use the warehouse picking list to check off items that you unpack. The shipping department has indicated on your picking list which items are packed in which boxes. For example, E10 Card 1 airframe hardware is located in box 1A. As you unpack the small parts cards, check off the card number only and stack these cards off to the side. After you've unpacked all the cards, verify receiving each item on the card against the picking list and place them back in the boxes in alphanumeric order. This will allow convenient retrieval and storage of the parts until you need them. Unpacking the body parts requires careful handling. Make sure when you open the container and remove the cross supports that the staples are not sticking out. Remove the staples or bend them out of the way so that you won't scratch the parts as you remove them. Also located in this container is the plexiglass windscreen. It has protective covering on both sides. However, be careful when removing and storing it. We will discuss working and handling a plexiglass windscreen and the standard construction practices later in this tape. Do not discard the 3/4 inch by 12 inch by 16 inch foam sheets as they are used as seat filler. Remember to remove the heat shield material from the tail boom container after you have removed the tail boom. Uncrate the airframe and remaining parts and check off against your picking list. You may want to purchase some cardboard parts bins, about 25 will be plenty, to place your hardware items in. Label the bins and you will have easy access to these items as needed.
This section will instruct the builder on standard construction procedures that should be utilized during the construction procedure. Please take the time to review these procedures and ensure they are followed throughout the fabricating and the assembly of the helicopter. If you require assistance with anything regarding the building, please call our customer service department. If you require any additional parts due to construction error, please call our parts department. When ordering parts, please identify the part by its specific part number and description. This will help ensure that you receive the correct part that you ordered. Use a letter D drill that is 246 thousandths for drilling 1/4 inch AN bolt holes for a tighter fit. 1/4-inch AN bolts are normally 3/1000ths undersize. In order to drill a hole closer to the exact size, always start with a slightly smaller drill, then finish the hole with a sharp drill of the exact size. When attempting to drill 4130 steel, always use a slow drill speed and apply pressure. Drills must be sharp. A dull drill will become hot and harden the material. Once the 4130 steel hardens, it will be almost impossible to make the drill cut through. In such a case, it will be necessary to heat the material with a torch until it is cherry red. Allow the material to cool completely. Do not quench before attempting to re-drill, this time with a sharp drill. To drill out a rivet, use the drill size of the rivet. Start drilling in the center of the rivet head and rotate the drill in a circle until the head of the rivet comes off. Stop drilling and use a punch to remove the shank. A torque wrench is a must for precision assembly. If you do not have one, purchase a 3/8 drive micrometer type and make sure that it has a scale on it marked in foot-pounds. The main blade retention bolts have the highest torque of any bolt on the ship and are torqued to 70 foot-pounds. Therefore, it is not necessary to have a torque wrench that reads over 100 foot-pounds. A heavier torque wrench will not give as accurate a reading at the low end of the scale, 6 to 10 foot-pounds. A dial indicator is an absolute must for main rotor blade rigging procedures. The indicator must have a dial that reads in 1000 increments, along with a magnetic base and gooseneck to hold it. A dial indicator can be used for checking the straightness of a shaft as shown. Support the ends of the shaft in V-blocks. Place the point of the dial indicator on top of the shaft in the center. The total indicator reading, TIR, for a 360-degree rotation can be noted. A dial indicator is also useful for checking relative height settings. Its main use on the EXEC 162F will be setting lead lag adjustments on the main rotor system. A 6-inch dial caliper with a needle trail of 1/1000th per revolution is a very useful tool for checking precise lengths and thicknesses. A protractor level is used throughout the construction and also for rigging procedures and rotor system adjustments. A quality protractor level will read in increments of 1 degree or less. In order to check the quality of the level you are purchasing, zero the bubble and place it on a level surface. Rotate the level 180 degrees to the surface and see if the bubble maintains its centered relationship. Also, the lines on each side of the bubble should be as close as possible to the end of the bubble. Do not force bolts into holes that are undersized. Pass a sharp drill of the appropriate size through the hole first. Do not use excess force to drive a bolt in place with a hammer. Whatever you put together will at some time have to be taken apart. Bear this in mind as you complete the construction. Fit shafts and mating parts carefully. If a bearing does not slide onto the appropriate shaft, do not hammer it in place. It is okay to tap lightly. Use 400 to 600 grit sandpaper to sand shaft down slightly until the bearing fits. In most cases, there will only be small burrs which need to be removed. The Rotorway EXEC 162F helicopter has several slip fits used in assembling shafts and bearings. A slip fit is one in which the bearing may be rotated onto the shaft by hand. The inner race should be rotated as the bearing is slid on the shaft. It will take a little pressure to force on a slip fit. However, no other means but hands will need to be used. In each case, in the final assembly, you will clean the surfaces and coat them with Loctite prior to installing the bearing. Several types of hardware used on Rotorway helicopters, including standard AN hardware and various military specifications, MS. Do not substitute the original hardware with bolts from lesser strength material. Hardware store variety nuts and bolts are normally mild steel and are not heat treated. AN hardware is twice as strong as most mild steel bolts of the same size. Elastic lock nuts, also called fiber lock nuts, are used in many places on the helicopter. These nuts are made with a fibrous collar in one end to keep them from vibrating off. After tightening, a minimum of 1 and a maximum of 3 threads should extend past the end of the nut. Nuts must not bottom out on the threads. Do not attempt to tap threads further on an AN bolt. It is acceptable to use up to 2 washers underneath the head of the bolt and or the nut prior to going to the next shorter length. Every length of every size of AN hardware is very difficult to find. Therefore, the use of extra washers is occasionally necessary. All bolts used as pivots or hinges in operation use castellated nuts and cotter pins. Examples: swash plate, scissor, and tail rotor actuator arm. In these applications, the nut must not be tightened to a point where the bolt is not free to rotate. Elastic lock nuts are not approved for this application. The cotter pin should fit snug in the hole. Do not use elastic lock nuts on bolts which have cotter pin holes in the threaded end, as the sharp edge of the hole will cut the locking device, rendering it ineffective. All bolts without elastic lock nuts or other locking devices must be safety wired to prevent them from vibrating loose during flight. Use the following torque specifications on 3/16 through 3/8 bolts unless otherwise noted in the construction drawings or manuals. Make sure bolt holes are perpendicular, 90 degrees to the surface involved, and are not oversized. A bolt in an incorrectly drilled hole will not carry its shear load until the surface that is in contact with the bolt has deformed. Contact Rotorway before drilling oversized or elongated holes in critical components, as there are many factors to be considered. The bolt grip length is the unthreaded portion of the bolt shank and should always be correct. Normally, the grip length is equal to the thickness of the objects being bolted together, though bolts of slightly longer length can be used with washers. Washers should also be used with bolt heads and nuts unless otherwise specified. A washer guards against mechanical damage to the material and can also help prevent corrosion. Cut brackets to size using the template supplied. If there is a grain direction specified on a template, paste the label on the material in that orientation. Use a 24 teeth per inch hacksaw blade or a low-speed bandsaw to cut out bracketry. Radius all internal corners smoothly with a rat tail file. This will help prevent cracking during the bending operation. If a bracket is to be bent, hold it in a vise with aluminum jaws or place a piece of scrap material in the vise jaws. As you hammer the bracket around the scrap, it will follow the radius of the scrap piece. Check for cracking after you have formed the bend. Heat may be applied during the process for brackets over 1/16 inch in thickness. 25 thousandths aluminum may be cut with left and right-hand metal cutting shears. 50 thousandths may be cut with a bandsaw or hacksaw. The same rule applies for bending aluminum as for 4130 steel. If the radius is too sharp, the material may crack. 25 thousandths aluminum may be clamped in a vise against a board and bent around the end of the board. Use caution when handling the plexiglass windscreen. The edges of the windscreen should be immediately sanded smooth to prevent possible cracking during the handling process. A file or air sander may be used for rough grinding, then finished by using 80 to 100 grit wet dry sandpaper. During any sanding process, be careful to support the material adequately in the area in which it is being worked. Be especially careful if you are using an air sander, 2 to 3 inches diameter recommended. Do not remove the protective film coating from the windscreen, doors, or other plexiglass components until all the work on them has been completed. When drilling cleco holes in plexiglass, try using a unibit or step drill. This type of drill is less likely to cause the material to crack. Before the windscreen is finally installed, the screw holes must be drilled oversized, using a 5/32 drill so that the windscreen is able to move slightly. There should not be any stress on the windscreen. The fasteners that hold the windscreen should be snug, not over-tightened. They should be secure and just able to be turned with a screwdriver. Clarity may be maintained in the windscreen by frequent polishing with mirror glaze. If a crack begins to form in plexiglass, immediately drill the end of the crack with a small drill, about 1/16 inch diameter, or the crack will propagate like a zipper. Warning: when working with fiberglass, make sure the area has adequate ventilation. Locate additional supplies, including acetone, rubber squeegee, 1 inch to 2 inch, wide brushes, and plenty of rags. Rubber gloves and eye protection should also be used. Prior to fiberglass application, prepare all surfaces by sanding and cleaning with acetone. Mix 20 drops of catalyst with 4 ounces of resin. The hotter the outside air temperature, the less catalyst is used. The resin should not take more than 35 minutes to kick. Test a small sample to get a feel for what works best. All components which are fiberglass to one another will use a layer of mat or cloth to bond the two surfaces together. Materials provided include 2-ounce mat and cloth. These may be used in 2 or 4 ply thicknesses as appropriate. 1 mat equals 1 ply. Do not start any fiberglass process unless you have some acetone and rags on hand for cleanup. Before Bondo is applied to any surface, the surface must be sanded slightly and cleaned with acetone. The Bondo material needs only a small amount of hardener and will kick within just a couple of minutes. Mix a small amount of Bondo material at one time. The material is best if applied with a small rubber squeegee. The primary rule in using Bondo is not to apply too much, so that a minimum amount of material needs to be removed before the next layer is applied. It is easy to mix another batch and apply more material, but the sanding process is time-consuming. Zeus fasteners are composed of a stud, grommet, and spring. The studs and springs are made of steel, cadmium plated to prevent corrosion. The grommet is made from aluminum alloy and holds the stud in place on the panel. The Zeus fastener locks with only 1/4 turn clockwise and unlocks counterclockwise. Use a hand drill to open a 1/8 inch hole to 5/16 inch for the Zeus fastener. Make a drill template from a strip of flat material, 1 3/4 inch wide and about 6 inches long. Drill a 5/16 inch hole, centered widthwise, close to one end. Install a Zeus stud in the hole and place a spring on the back of the strip parallel to the end. Use the spring to locate and drill 2 holes for the 1/8 inch pop rivets. Remove the stud and spring and install a rod or a short 5/16 inch bolt with the thread sawed off in the 5/16 inch hole. Use the drill template to drill the 1/8 inch pop rivet holes. Hand twist a large drill bit to countersink the 1/8 inch pop rivet holes. Use a hand drill and a 3/8 inch bit to open the Zeus hole. Then install the spring wire with the pop rivets. Install the spring as shown. Use a hand drill and a 3-inch bit to open the hole for the grommet. Install the grommet with the large end on the same side that the head of the stud will be on. Place it on a hard surface with the pointed end of the tool toward the grommet. Hammer to expand the small end. Install the Zeus stud. Place the head of the Zeus stud on a hard surface and place the open end of the tool over the shank of the stud. Hit the pointed end of the tool to lock the Zeus stud to the grommet. Remove the tool and check for even compression of the grommet. Use a screwdriver to turn and free up the Zeus stud. When installing a nut plate, use a cleco to hold the nut plate. Use the nut plate as a template and drill the holes for the pop rivets. Using a large drill bit, countersink the holes for the pop rivets. Use a hand drill and open the hole for the size of screw or bolt to be used. Use a pop rivet gun to install the nut plate rivets. When installing several nut plates, it is recommended to make a drill template from a flat strip of metal, 1 3/4 inches wide by 6 inches long.
This section will instruct the builder to drill and cut the bushings in the airframe to the correct size. Mount the landing gear to the skids, level the airframe on the landing gear, mount the airframe to the landing gear, tap and install body support pads, and fabricate the battery strap. Locate the following components. Reference construction prints E10 2000 airframe landing gear and E16 2000 directional control. These are the skid tubes. Note, the rear of the skid will have the smallest bend. This is the rear landing gear. This is the front landing gear. And these are the 4 skid end plugs. The first step in this section is to mount the landing gear to the skid tubes. To locate the position of the rear landing gear on the skid tubes, reference construction print E10-2000. It shows the rear edge of the landing gear shoe should be 15 3/4 inches from the rear end of the skid tube. Using a tape measure, make a mark on both skids at the proper location. Position the skid tubes on the floor. Note, make sure the skid tube with the steel insert, located on the front tip, is on the passenger side. Mount the rear landing gear on the skids so that the rear edge of the shoe is on the mark. Slide a hose clamp over the rear of the shoe to prevent the landing gear from falling over. Leave the clamp loose so you can rotate the skid. Rotate the skids so the turned up ends of the skids are parallel and not leaning in or out. Tighten the hose clamp and check to see that the skid tube and the shoe have the proper fit. You may find it necessary to use a C-clamp to squeeze the skid tube into the shoe. Cut a 7/8 inch thick board the same length of a landing gear shoe and mark 7/8 inch from both ends. Place this board next to the shoe and use a center punch to mark the hole location. It is important to check the position of the shoe on the skid, the rotation of the skid tube, and that the reinforced skid is on the passenger side before doing any drilling. For best results, mark both sides and drill with a sharp 1/4 inch drill bit from both sides, then pass the drill through. Install the 1/4 inch by 2 3/8 inch bolts and fiber lock nuts and remove the hose clamps. Cut a board to fit between the shoes of the front landing gear. To find the location of the front landing gear, locate and mark on both skid tubes 40 1/4 inches from the front edge of the rear landing gear shoes. Place the board between the skid tubes, midway between the 40 1/4 inch marks and the rear landing gear. This board is to aid in getting the alignment of the front landing gear shoe on the skids. The distance between the rear and the front landing gear are not the same until all the weight of the helicopter is on the landing gear. Now, position the front landing gear on the skids and be sure to align the rear of the shoe with the marks on the skids. Place the hose clamps around the shoes and the skids. Use the same board and procedure you used on the rear landing gear shoes to locate and drill the holes to fasten the front landing gear to the skids. Clean the end of the skids and plugs, checking for burrs on anything that would prevent the plugs from being installed. Use a file to remove any burrs. Install the plugs by driving them in with a large mallet or a hammer on a block of wood until they are all the way in to the shoulder of the plug. Locate and drill and install the 2 pop rivets that hold the plugs in position. Note, the rivets on the passenger front skid must be countersunk so the ballast weight can be installed and removed without binding. If you desire, you can countersink the pop rivets on all the plugs. This is the landing gear mounted to the skid tubes. The 162F airframe. Located on each side of the airframe near the front are bushings for the front landing gear attachments. Drill the bushings with a sharp 1/4 inch drill bit. Use plenty of cutting oil while drilling. Before mounting the airframe to the landing gear, you will need to check to see if the tail boom braces will make a difference in the lateral square tube angle when they are bolted in place or when they are removed. With the tail boom braces installed, level the rear square tube laterally on the floor or table. Remove the braces and check to see if the square tube is still level laterally. If there is a change in the angle, make note of the difference. With the 2 tail boom supports removed from the airframe, have someone help you or pick up the airframe in this way and place the rear of the airframe on the rear landing gear as shown. With the airframe sitting on the landing gear, you will need to check the angle of the square drive tubes with a level. If necessary, you will need to grind away some of the bracket or shim between the bracket and the landing gear tube. The shims may be from a 20,000th of an inch to a 1/4 of an inch thick to achieve the angles called for on the square drive tubes. Note: if more than a 1/4 inch of shims are required, contact Rotorway customer service. Remember, all of the weight of the helicopter must be on the 3/8 inch bolts. If the bracket rests on the landing gear tube, it will eventually wear through the tube and cause it to break. When checking the square tube angle, you must remember to compensate for the difference, if any, when you remove the tail boom braces. When the front of the airframe is held down, you will notice that the airframe bushings need to be shortened. Mark the bushings, then remove the airframe and cut the bushings so the airframe will go between the brackets. Use a file to square off the ends of the bushings. Use a 1/4 inch bolt to check the ends of the bushings. To verify the end of the bushing is 90 degrees to the hole, make sure the head of the bolt is making contact with the end of the bushing all the way around. Now lower the front of the airframe between the front landing gear attachment brackets. This should be a snug fit. Place a 20,000th inch shim between the front landing gear and the airframe on each side. Use clamps to hold in position. Use C-clamps to hold the airframe to the landing gear in the correct position. Do not place a clamp where it will interfere with the drilling and mounting bolts. Note: before drilling any holes in the brackets, make the following checks. Make sure the skids are level. Check to see that there's proper clearance around the brackets and the landing gear tubes. Make sure that the rear square drive tube is level laterally when the braces are installed. The fore and aft square drive tube should have a 4 1/2 degree downward tilt towards the front. Also check that the airframe is sitting on the landing gear straight. Use a sharp 3/8 inch drill bit and locate the center of the hole in the rear gear bracket. Then use a smaller bit to make a pilot hole. Then follow with a 3/8 inch bit. Hold the tail boom braces by the hole and determine if any material needs to be ground off the square corners on the ends. Then install the 3/8 inch bolts and the supplied fiber lock nuts. With a clamp holding it in position, drill a 1/4 inch bolt hole in the front landing gear attachment, using the bushing as a guide, and install the bolts. Next, drill the 1/4 inch rear landing gear bolt holes and install the bolts. The landing gear bolted to the airframe and skid tubes. Referring to construction print E16-2000, locate and grind the 4 bushings in the front airframe cross tube so they extend about 1/4 of an inch above the tube. Tap the 4 bushings with a 5/16 inch by 18 threads per inch tap. Use plenty of thread cutting oil when tapping. Install the body support adjustment pads into the tap bushings using a 5/16" jam nut on each. Determine the length and position of the holes for the retention strap. Use the battery or a cardboard box that will fit the battery box to determine the length of the 5/16" studs. With the supplied 5/16" lock nuts, install them as shown here. Use a wing nut and a lock nut to hold the stud while you position the rear lock nuts. Use 3M weather stripping adhesive to glue the rubber to the steel strap. This section will instruct the builder to drill and cut the bushings in the airframe to the correct size to install the lower engine mount and install the fuel system mount tube to the airframe. Locate the following components. Reference Construction Prints E13 2000 engine mount. This is the engine mount weldment as received from Rotorway. This is the engine mount support ring and hardware. Note: do not cut out shims for the engine mount at this time. When the engine is ready to be installed, determine which shims are needed and cut out only what is necessary. Use a hand drill with a sharp 5/16" drill bit to bore out the 4 bushings for the lower engine mount. When installed, the engine mount must be level fore and aft and laterally in relationship to the square drive mount tubes of the airframe. The distance from the top of the engine mount plate to the bottom of the square drive tube should be 24 inches. To fit the engine mount so that it is level in the relationship to the drive tubes, it may be necessary to shorten the upper bushings. The bushing material can be removed to as short as 1/16 of an inch away from the weld. Remember, the ends of all the bushings must be 90 degrees to the hole. On the lower passenger side bolt, shorten the bushing to allow for 2 battery cable ends, washer, and nut. Install the lower engine mount. In most cases, this is a snug fit. However, do not apply excessive force to position the components together. Now, check to see if the engine mount is level laterally and fore and aft in relationship to the square drive tubes. Verify the distance between the top of the engine mount plate and the bottom of the square drive tube is 24 inches. Check the location of the support ring. Shims will be installed later to change the height of the engine. Add O-shaped shims between the engine mount and the rubber ring to raise the engine, or you will add Y-shaped shims between the engine mount and the support ring weldment to lower the engine. Reference template E13-1. However, do not cut out the shims at this time, but wait until installing the engine to determine which shims are needed. Use the support ring weldment as a template to mark the outside diameter of the engine mount rubber to be cut. The rubber marked where it is to be cut. Cut on a line and check the fit in the support ring weldment. The rubber should have a snug fit inside the ring weldment. The inside diameter's cut's actual dimension should be 2.650 inches as in the construction print. Note, if necessary, the inside hole can be offset from the outside diameter to allow for any centerline offset of the lower mount. The rubber should fit snug inside the support ring and around the bottom of the engine. Fuel system mount tube. This is the fuel system mount tube as received from Rotorway. Located on E25 card 1F and E25 card 2F is the hardware necessary to mount the fuel system tube. Cut the 1-inch long square tube diagonally into 2 pieces to make the tabs for the fuel system mount tube. Bend if necessary to fit the cross tube and the plates. Mark the location of the holes on the tabs and drill the 2 3/16-inch holes. Now locate the position of the tabs as per the construction manual and mark the hole location using the tabs as a template. Before doing any drilling, check to verify that the mount tube will be level. Drill the holes in the landing gear attachment brackets. Note, when drilling these holes, drill only through the inner plate of the landing gear bracket. Install the bolts from inside the bracket. It may be necessary to trim the ends of the fuel system mount tube to fit. The short square tube should be on center. Trim the ends so that they are equal distance from the short tube. Locate and drill the holes in the mount tube, then position the tube on the tabs and mark and drill the holes in the tabs. Bolt the fuel system tube to the tabs with the supplied bolts. the engine mount and fuel tube mounted to the airframe. This section will instruct the builder to drill the ground handling wheel shaft and mount the wheels. This section will also demonstrate the proper ground handling techniques. Locate the following components. Note: the cotter pins and flat washers for the wheel mounting are taped to the ground handling weldment. Reference construction prints E37-2000 ground handling wheels. To verify the hole location for the cotter pin, install the wheel and washer on the shaft. Mark and drill the 1/8 inch hole in the shaft end. Install the wheel and 5/8 inch washer. Then install and bend the cotter pin to prevent the wheel from coming off the shaft. The ground handling wheels enable the ship to be easily moved on the ground. Install the shaft of each ground wheel assembly at each rear brake shoe. Pressing down on the handle will raise the rear part of the skid and use the ground handling wheel hook to latch in place. Always keep your hand on the top of the J-hook to prevent your fingers from being smashed in the event the welds break or the handle slips out of your hand. When ground handling the completed aircraft, use one hand to press down on the tail boom at the third bulkhead, guide with the other hand, placing it on the horizontal trim fin close to the tail boom. The main rotor blade should be parallel to the tail boom when ground handling the aircraft. It can be held as shown. Note: it is easier to move the completed ship with the ballast weight in the rear position. Also, caution should be used when using the ground handling wheels at different stages of the construction. The center of gravity can suddenly be shifted when using the ground handling wheels without some of the components installed.
At this time, Rotorway recommends the metal components to be bead blasted. Even though Rotorway has visually inspected each weld prior to shipping the components, bead blasting creates another good opportunity to inspect the components in the unlikely event of cracks because of the thermal process involved. Rotorway also recommends the components be painted with a two-part epoxy paint and use a light-colored paint such as a light gray. This will also ease visual inspection of welds in the event of a stress crack. If you are not set up with the correct equipment or a spray booth, you may find it best to have a professional paint facility do the work for you. Another paint option for the metal components is powder coating. It is a very durable finish, and powder coatings also come in epoxy-based finishes for fuel and oil-resistant protection. The following video segment demonstrates the powder coating process with an EXEC 162F airframe and some of its components.
Basically, now what we're going to do is we're going to take the frame, we're going to bring it into the shop, we're going to rack it, we're going to stage it, get it ready for the power washing, which we'll go ahead and power wash. At that time, when that's done, it's going to be placed in the oven to dry. When it comes out of the oven, it's going to be placed into the paint booth where the powder will be applied. Then it goes back into the oven one more time for the actual baking process. When it comes out of the oven, then once it cools down to the touch, we'll cut it off the rack, and then you can basically take it out of here. We'll wrap it, of course, to protect it against scratching, that type of thing. In your particular case, I think it makes good sense to use an epoxy formulation for one real important reason. There's going to be a lot of fluids, such as hydraulics and gas and oils, that type of thing. Some of these fluids have high concentrations of detergents, which on a polyester powder could mar it or mark it. So we're going to use an epoxy powder for your particular project here, which is pretty much resistant to any of those type of fluids. So you can pretty much expect a real long life out of the finish. The paint you selected was a wrinkle type paint, which means it'll have a texture on it. This paint is specially designed to actually wrinkle in the oven, which is what it's done. It gives it a real rich consistency. You can also see all the tubing. It's completely wrapped around all the tubing. It's actually in some of the areas is smoothing out some of the welds, gives it a nice, almost like a poured plastic look, if you will.
Reassemble the airframe to the gear and skids and install tail boom supports in engine mount. Check and verify the square tube angles are correct. This section will instruct the builder on the construction of tunnel inspection doors, mounting tail boom to airframe, mounting horizontal and vertical trim fins, fabrication and installation of the tail rotor assembly. This section will be subdivided into 4 parts. Locate the following components for the first part of this section. Reference construction print E09-2000 tail boom. Referring to construction print E09-2000, it shows that the tunnel inspection doors are 13 3/4 of an inch in length. From the supplied material, measure and cut the 2 doors to the proper length. Referring to the construction print, mark the hole locations of the Zeus buttons as shown. Hand form the radius of the inspection doors to match the tail boom with a large diameter pipe. When satisfied with the radius, locate and drill 1/8 of an inch holes for clecos. Drill 1 hole at a time, then cleco that hole, then drill the next hole. Remember that the hole for the Zeus button will be 3/8 of an inch, so make sure the hole location is not too close to the edge of the tail boom door opening or the removable door panel. Install Zeus buttons when satisfied with fit. Refer to Section 1, Construction Practices on Proper Installation of Zeus buttons, grommets, and springs. The second part of this section is mounting the tail boom to the airframe. Locate the following components and parts. Reference construction print E09-2000. Note, when mounting the tail boom to the airframe, be sure to hold the measurement to the square drive tube and also hold the correct tail boom angle. Try to use the same level for all the angles that are to be checked. The quality of level or protractor used during the construction process can greatly affect the results of the project. Care should be taken to utilize the most accurate tools available for positioning. The aircraft's center line can be found by using the center of the forward cross tube and the center of the cross tube at the rear of the airframe where the tail boom support tubes are attached. Pull a string tight just above the floor and level the skids laterally. Use shims if necessary to level the skids. Use plumbs to place the aircraft's center line on the string. Hang the plumbs on the center of the forward cross tube and the center of the rear cross tube. Note, the end of the tail boom attachment brackets should be radiused slightly before installation. Notice the 2 brackets with a greater angle are the upper brackets. Insert the tail boom attachment brackets into the airframe. Very important, use caution when positioning and mounting the tail boom to prevent it from falling, causing damage to a bulkhead or the skin. A wooden support can be fabricated or use adjustable sawhorses to position the tail boom over the center line. A line suspended from above between the 3rd and 4th bulkhead will also help you position the tail boom for the proper angle. To make the tail boom slide into position easier, make sure you have the top of the tail boom angle close to its final position. Slide the tail boom into the attachment brackets. Use a quick grip clamp to help draw the tail boom forward. Make a loop with a piece of string to go around the tail boom end and hang the plumb from the string as shown. With the tail boom inside all 4 attachment brackets, center the end of the tail boom over the centerline string. To find the proper tail boom angle, measure the angle of the 4F square drive tube and add 2.5 degrees. This is the angle that the top of your ship's tail boom should be. The distance from the back of the square drive tube, where the top of the secondary drive mounts, to the front of the number 1 bulkhead should be 22.5 to 23 inches. Check to ensure that the flat part of the tail boom attachment brackets are over the ears in the number 1 bulkhead and the flat extends beyond the front of the bulkhead. With the skids leveled laterally, check the vertical alignment by aligning the 2 small holes drilled in the number 1 bulkhead with a straight edge and a level. Using the same method, check the number 4 bulkhead. If number 4 is not leveled vertically, rotate the tail boom to achieve vertical alignment. The intent is to have the best vertical positioning of the 4th bulkhead while maintaining the location of the tail boom attachment brackets over the ears in the number 1 bulkhead. Use C-clamps to hold the tail boom in place until the bolt holes are drilled and the bolts are installed. Before drilling any bolt holes in the tail boom attachment brackets, perform the following checks and measurements. Number 1, check the vertical alignment of bulkhead number 1 and number 4. 2, check that the flat part of the tail boom attachment brackets are over the ears of number 1 bulkhead and the flat extends beyond the front of the bulkhead. 3, measure the angle of the square tubes fore and aft and add 2.5 degrees to verify the angle of the top of the tail boom. 4, measure the distance from the back edge of the square drive tube to the front of number 1 bulkhead and verify it is between 22.5 inches to 23 inches. Locate, drill, and install the tail boom bracket bolts per the construction print. Note: the lower tail boom bracket front bolts should be horizontal through the 1-inch airframe tubes. They will also be used to hold the radiator mounting straps. Do not drill these 2 bolt holes in the airframe at this time. The location should be verified when the radiator is installed. The third part of this section is fabricating the horizontal winglets and mounting the horizontal trim fin to the tail boom. Locate the following components. Reference construction print E09-2001, vertical and horizontal trim fins. A small hole is pre-drilled where the horizontal trim fin mounts 1/4 inch below the tail boom centerline. Install a small straight rod with equal amounts extending from each side of the boom. It must be level. The distance from the top center of the number 1 bulkhead to each end of the rod must be equal. Using this method will ensure the horizontal fin is level and 90 degrees to the aircraft centerline. Enlarge the hole to fit the trim fin spar, making sure that the spar will be level when installed. The hole will be slightly larger than 7/8 of an inch. Make two 4-inch diameter doublers from 25 thousandths aluminum and drill a 7/8 inch hole in the center of each. Drill 6 holes at equal distance that will secure the doubler to the inside wall of the tail boom with 1/8 inch rivets. To match hole alignment, place the doubler on the outside wall and drill 1 hole and cleco in place. Then drill the remaining 1/8 inch holes and cleco in place. Now remove the clecos and move the doubler to the inside and rivet in place. Note, sand the area around rivet holes before installing the rivets. Scotch-Brite works well for this. Locate the winglet halves. Note, there is a pilot and passenger side. Fit the fiberglass winglet halves by trimming and sanding. Trim away only what is necessary to get a good fit. Use clecos to hold the halves together during this procedure. Check to make sure the leading edge and the trailing edge of the winglets match the horizontal fin assembly. Bond halves to each other using a layer of fiberglass between seams. When dry, fill any low spots with Bondo and sand smooth. Locate the horizontal fin assembly. Make sure the head of the rivets on the trailing edge are on the top side when mounting the winglets. The brackets that hold the fin assembly to the tail boom will only fit if the head of the rivets are on the top side. Insert a short piece of 7/8 inch diameter tubing in the end of the airfoil. Clamp the airfoil against the tube. This will ensure that the fin is the same shape here as it is on the other end. Place the wooden end plug material against the end of the fin and mark the outline of the airfoil. Note the width of the end plug should be the full thickness of the material, about 1 5/8 inches wide. The end plugs will be used to splice the winglets to the horizontal fins. Cut out and shape each end plug so that half fits into the fin and half fits into the winglet. You may have to trim or sand the winglet side for better fit. Mark the cord line on each plug. Insert the end plugs halfway into the fin assembly on the tail boom. Align the cord line on the end plugs to be parallel with the top of the tail boom. While holding this position, drill the holes in the trim fin brackets to mark the location on the tail boom. Then remove the fin assembly. Locate the nut plates for the horizontal trim fin according to the previously drilled holes. Install the nut plates inside the tail boom. Use a small bit to drill a pilot hole for the screws and 5/16 inch bit for the countersink. And twist the 5/16 inch bits so that it will not go all the way through the fiberglass material. Attach the winglets to the fin using blade glue to bond the wood end plug to both pieces. Secure each winglet with 16 countersunk wood screws. Peel back the protective film from the aluminum and sand the fin in the area to be bonded. Apply 2 layers of the fiberglass cloth and resin over the seam. When dry, sand the fiberglassed area. Fill any low spots with Bondo and sand smooth. Mount the assembly on the tail boom. This is the overall view of the completed horizontal trim fin with winglets installed. The fourth part of this section is fabricating and installing the tail rotor assembly and vertical trim fin installation. Locate the following components and parts. Reference construction prints: E09-2000 tail boom, E09-2001 vertical and horizontal trim fins, and E17-2001 tail rotor. Locate per the construction print E17-2000 the parts to fabricate the tail rotor slider assembly. There are 2 stringers riveted together to form each slider rail. This animation shows how the fabricated parts are configured. Study the construction prints carefully for the correct dimensions as you fabricate the parts of the tail rotor slider assembly. Locate per the construction print E17-2000 the parts necessary to fabricate the bearing plates. Using template E17-1, cut out and drill holes in the bearing mounting plate slider straps. When drilling the 1/8 inch holes, it is recommended to stack and drill 2 parts at a time. Install a cleco, then as each hole is drilled, install another cleco. Keep each pair as a set. Use template E17-2 to make the tail rotor bearing mounting plates. Using each set of slider straps as a template, drill and rivet the straps to the bearing mounting plate per construction print E17-2001. Make the bearing plate adjustment angles and mount 1 on each of the bearing mounting plates. Check to verify the bearing plates move smoothly on the slider rails. To help make mounting the slider rails to the number 4 bulkhead easier, use a threaded rod and nuts installed as shown here to keep the bearing plates equal distance on the X-axis. Position the assembly into the end of the tail boom. Then slide the bearing plates as far forward as they will go. The sides must be level vertically 90 degrees to the ground. The slider rails must be parallel from end to end, in line with the stringers inside the lip and tight against the number 4 bulkhead. The vertical center line of the slider rail assembly must be matched to the vertical center line of the tail boom, so when installed will slide smoothly during belt tensioning. Measure the inside diameter of the bulkhead and fabricate a fixture from a block of wood to hold the stringers in place. Drill a large hole in the middle of the wood block to help in removal. Fabricate the vertical tail fin bracket using template E09-1. When bending, be sure to make a radius in the bends. One way to do this is to bend the part over a piece of scrap material. Before drilling the holes through the tail boom, make sure of the following. 1. Make certain that the tail rotor slider assembly rails are tight against the number 4 bulkhead. Use the wood block to hold their position. 2. The tail rotor slider is level 90 degrees in relation to the ground, and the rails are parallel. 3. The vertical center line of the tail rotor slider assembly must match the vertical center line of the number 4 bulkhead. 4. The slider assembly should be level in both vertical and horizontal positions. Drill the 4 bolts that hold the assembly to the tail boom with a 1/8 of an inch bit and cleco 1 hole at a time. Now drill the 3/16 of an inch holes and install the bolts to hold the slider rails to the tail boom. These bolts will go through the stringers, bulkhead, and skin, plus the vertical trim fin bracket on the pilot side. The bolts on the pilot side also hold the vertical trim fin bracket. Match drill the 3/16 holes one at a time while maintaining the bracket 90 degrees to the ground. Use 4 rivets as per the construction print to fasten the stringers to the rear of the tail boom skin when bolts have been installed. Cut out the vertical trim fin angle doubler from 50 thousandths material. Hold in position on the outside of the tail boom and drill 1/8 inch holes in doubler and tail boom. Now move the doubler to the inside and cleco in position, then rivet in place. Cut out and fit the 2 wood end plugs on the bottom of the fin. Use glue and wood screws to hold in place. Cut out and fit the end plug on the top. You may also choose to use a thicker piece of wood to create a wood end plug fairing form to fit the top of the vertical fin. Bond in place with glue and wood screws. With the vertical trim fin bracket bolted in place, position the vertical trim fin assembly with a quick grip clamp. To find the correct angle of the trim fin's leading edge and the top of the tail boom, use a piece of cardboard with the correct range marked 126 degrees to 128 degrees. Hold this position and mark the outline of the vertical trim fin bracket against the fin. Remove the vertical trim fin assembly and position the bracket in place according to the outline. The holes in the vertical trim fin bracket must be in line with fin spar when positioning. Reinstall the bracket to the tail boom and install the vertical fin assembly with the two 1/4 inch bolts and spacers. The construction print shows the location of the bolt hole for the rear vertical trim fin mount. Drill the 3/16 inch hole for the rear vertical trim fin bolt and spacer. Install the nut plate inside the tail boom and install the 3/16 inch bolt and the spacer. Note, this spacer may need to be trimmed to adjust the vertical trim fin assembly. Later, when the main shaft is installed, you'll be shown how to align the cord line of the airfoil to 15 to 16 inches from the center of the main shaft to the pilot's side of the ship. Use template E17-3 to make the tail rotor pitch actuator arms. Drill actuator arms per the template. Reference the construction print E17-2000 and assemble the pitch actuator arms using the spacers, bolts, and pivot casting. Note, apply grease to the bolt that goes through the pivot casting. Make sure that the actuator arm spacers are of equal length and that they match the dimension of the pivot casting and the two washers. Complete the assembly. Note, on bolts requiring cotter pins, first find the correct tension of the nut, then drill the cotter pin hole through the bolt in line with the slots of the nut. Shown is the cotter pin installed in the bolt with castellated nut. However, do not install cotter pin at this time. Mount the pitch actuator assembly to the bearing mounting plate and safety wire the two bolts to each other. Install the bearing assemblies to the bearing plates. Note the extended inner races of the bearings must be facing towards each other. Install the belt adjustment rods into the bearing plate adjustment angle. Fit the end caps to the tail rotor blades. It may be necessary to bend the cap slightly to achieve a good fit. Note, do not install the pop rivets until after balancing the blades. The cap does not need to fit perfectly to the airfoil of the blades. Countersink just enough to make the head of the pop rivet flush with the airfoil. This shows how the end cap will look when final installed. Do not install pop rivets until blades have been balanced, which will be shown later in this section. Install the grease fittings in the tail rotor barrel. Then install the tail rotor barrel on the shaft. Install the inner snap rings with numbers or flat side facing the shaft. The opening in the snap rings should be in line with the shaft. Mount the O-rings on the pitch pins. Grease the pitch pins, thrust bearings, and alignment bearings, and assemble as shown on print E17-2000. Install the pitch pin assembly in the tail rotor barrel. Be sure not to damage the O-ring. Also make sure the O-ring stays in the groove at the head of the pitch pin. Then install the outer snap rings with the flat side facing out and the openings parallel to the tail rotor shaft. Use 2 snap rings on each pitch pin. Position the pitch horns on the blade spars. Install the blades and pitch horns on the pitch pins with the supplied bolts. Build a balancing fixture like the one shown using a vise, a 2x4 board, and 2 pieces of 50 thousandths aluminum. The top edges must be level in all directions. Use small pieces of foam to wedge in between the shaft and the barrel opening as shown to keep the tail rotor barrel 90 degrees to the shaft while balancing. Note, blades must be forced out against the thrust bearings so that they will be in the same position as if forced out by centrifugal force when in flight. Using the tail rotor pulley and collider assembly as counterbalance, place tail rotor shaft and blades on balanced device. Balance the blades horizontally. If weight is needed, add it to the inside of the airfoil at the tip. Balance the tail rotor vertically. If weight is needed to achieve vertical balance, add washers to the pitch horn bolt. If more than 4 regular 5/16" washers are required, contact Rotorway customer service. Install the bearing mounting plates in the slider rails. Note, part of the tail boom must be cut out for clearance of the actuator arms. Only remove what is necessary to clear the arms. When the direction control cable is installed later in the construction process, final trimming will be necessary. The tail rotor drive assembly can sit back for the time being while remaining components are fitted. Install the tail rotor shaft along with the lock rings, pulley, and tail rotor belt into the bearings so the end of the shaft is even with the bearing on the pilot side. The sliders should be 5 inches apart. The pulley should be located off-center 1/2 inch to the tail rotor side for proper clearance and belt alignment. To verify proper belt clearance, secure the belt to the horizontal fin cross tube with wire ties. Now, looking from the rear, check belt clearance through the notches in the 4th bulkhead. Mark the shaft for the pulley location. Before measuring for the spacers, make sure you have the lock rings installed and rotated into position. Drill the hole for the 1/4 inch bolt that pins the tail rotor drive pulley to the shaft on assembly. This hole must be a precision fit. Use a 3/16" drill first and then drill to size with a letter D drill. In final installation in the ship, set the lock rings against the direction of rotation. Loctite the bearings to the shaft for maximum longevity. Let the Loctite cure before locking the lock rings. Do not final install at this time. Now install the tail rotor assembly into the tail boom. Also install the tail rotor belt. Make sure to use the 112-inch belt as the rear belt. Bolt the cross brace into position. Construction print E17-2001 shows the details of the actuator clevis. Note the bolt hole sizes and their locations. Also, note the hole center's measurement is between 2 1/4 inches to 2 3/8 inches. This must be verified on assembly. Position the carriage slider assembly so that the key in the shaft shows 1/4 inch. Position the actuator arm so that it just misses the bearing flange on the passenger side. Measure the distance between the hole centers in the carriage assembly and the actuator arms. Using this measurement, locate and drill the holes in the slider to actuator arm clevis. Install the clevis. Bolt the clevis to the slider, then remove the pivot bolt, and then install the bolts and castle nuts to the pitch actuator arms. Then reinstall the pivot bolt. Note the bolts with castle nuts must be installed with a cotter pin on final installation. As per the construction print, install the pitch links and rod ends. If necessary, use a washer as a spacer between the rod end and the pitch horn to get the rod end centered on the pivot bolt. Use a 5/16" washer to center over the pivot bolt. Note, whatever weight is added to the one pitch horn must be added to the other one once the tail rotor blades have been balanced. If during the balancing of the tail rotor assembly you needed to add washers for vertical balance, it must be installed between the rod end and the head of the bolt. Cut the tail boom skin to clear the actuator arms. Only remove what is necessary to clear the arms. The tail boom skin and fiberglass can be final trimmed as necessary when the tail rotor cable and belts are fitted and adjusted. With a fiberglass tail cone cover over the end of the tail boom, overlap the end of the tail boom skin 1 1/4 inches. Hold the cover tight on the fin side and drill a 1/8 inch hole on top. Hold together with clecos. Fill the small end of the cover with fiberglass mat and fit to the tail boom and tail cone cover. After the tail cone cover and slider cover are fitted, install the nut plates and then install the covers. This shows the tail section with the tail rotor, vertical trim fin, and tail cone covers installed. Note, specific procedures for tensioning and adjusting the tail rotor belts are found in the rigging section. During initial running of your helicopter, these belts must be checked and adjusted after every 30 minutes until they do not stretch anymore.